Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard, and I'm joined as usual by my co-host Nikolay, founder of Postgres AI. Hey Nikolay.
Hi Michael, hi.
And today we are joined by special guest Gwen Shapira, co-founder and chief product officer at Nile, to talk all things multi-tenancy. Hello Gwen, thank you for joining us.
Thank you for having me. It's very exciting for me to be on your show.
Oh, we're excited to have you, thank you. So, to start, perhaps you could give us a little bit of background and what got you interested in the topic of multi-tenancy in general.
As many things, it started with an incident, but this time not actually one of mine. So when my co-founder and I started Nile, we actually started with a very different idea. After about 9 months, we were like, this idea is not working very well. We developed some things. We're not finding the market we hope to find. We were sitting in a hackerspace over in Mountain View, and we were like, what did we learn? We talked to 200 companies all doing SaaS. What have we found out as a result? And the thing that called to us is that very early on, basically when the first lines of code are getting written, you have to choose a multi-tenancy model. And then about 2, 3, or 4 years later, depending on how fast you're growing, you have to change it. Mm-hmm. And we heard a lot of stories on what caused people to change it and whether they regret earlier choices or they're like, we didn't know better, and how things went for them. And then we started looking in different blogs, and we found so many by very famous companies with either incidents where something that was done to a single tenant caused a whole chain of events that took down their entire system, sometimes for days. And also a lot of slightly better stories, how we sharded our highly multi-tenant database. And we found story after story after story on how people had to re-architect their entire database, which is, as you guys know, extremely painful to do after you're a successful company 3 years in. And we're like, this is a good problem. So many people have it. It is so common. My past was in databases, not as much Postgres, more Oracle and MySQL, but I've seen this problem again and again in all kinds of companies. My co-founder's seen this problem again and again in all kinds of companies. Like, this is such a good problem. Everyone has it and nobody's working on it. Why is nobody working on it? And that's how we got into it.
Yeah, nice. Should we go back then in terms of how do you like to describe the different models or the different options that people have in the early stages?
Yeah, so everyone basically starts with 1 out of 2, and I'm using AWS terminology, even though there is other terminology that people apply to it. AWS calls it the pooled model versus isolated model. Mm-hmm. And in a pooled model, you basically create your tables as normal and then add a tenant ID column to each and every one of your tables, pretty much. Some, maybe not everyone, some have like shared data, but most of your tables are going to end up with a tenant ID column that tells you which tenant this row belongs to. Very easy when you start out. And all you have to do is sprinkle some work clauses every now and then, and you're pretty much good to go. How hard can it possibly be? The places where it gets you is that you have no isolation. Everyone is in one big pool. And if you have a problem tenant, if someone grows really, really large and suddenly you need to queries start getting slow for them, if you need to do an upgrade and one customer absolutely refuses to accept changes or needs their own time window, there is a lot of different ways you may discover that by putting all your customers in one big pool, you save a lot of effort, you save a lot of money. This is by far the cheapest option you're going to have. It's shared resources in one database. but you are not allowing yourself to do anything specific for any one customer should they need it. The other approach is basically the reverse. It gives every customer its own database, or sometimes it's its own schema. They still count as isolated, even though it's not all that isolated. You share quite a lot in that scenario, but the schema is separate, and it's quite a bit easier to move them out if needed, if the schema is separated. And in this scenario, first of all, there is a nice benefit that you get help from a lot of popular frameworks. I think Ruby has I think it's called apartment plugin for having this kind of multi-tenancy model. Django has something, so a lot of very popular frameworks have something that helps you in that model. But if you accidentally grow to a large number of databases, it starts being very painful. Obviously, a database with large number of objects is no longer as easy to work with. Suddenly you start learning how much space in memory the catalog can really take when you have connections. Suddenly you start learning that pgdump can take a very long time. If you actually have a database for each tenant, then doing any kind of maintenance on 100 databases is already not fun. If you end up going into 1,000 databases, it's really not fun. And if you think about it, a lot of SaaS have customers in the hundreds of thousands, not just thousands. So it becomes very painful exactly when you grow.
Yeah, for example, upgrade includes dump or restore schema. And we had cases with 250,000 tables, 2 million indexes. Well, indexes they are not dumped, but tables
exactly.
need to be dumped.
This is worse than not dumped, right? If only we could dump indexes.
Yeah, and then you need to update statistics after upgrade for all of those tables. It's nightmare, honestly.
Yeah. On the other hand, at least you get to do it to a customer at a time. Imagine that everyone is in one really big database and now you have to upgrade all of them together.
Yeah. Yeah, it's painful, all this.
Yeah, and then there is the mixed model where I think pretty much everyone ends up with, where you basically you start with the pool model, and as you grow, you shard it, but you're actually pretty smart and you realize that not all customers are of the same size, and you can have some dedicated shards for your biggest or most sensitive or most demanding customers. And this is, I think, if you look 5 years into the life of a company, I would say that this is the dominant model. Some variation of we have shared databases with a pool and then some dedicated databases with specific customers.
What is the problem we're trying to solve? Is it security or performance or both? And if we go back to some customers, they share this pool, it affects security goal, right? So we don't achieve it.
Absolutely. So this is one driver that people actually start with the isolated model.
Security.
They know that they're going into a sensitive area. They're focusing on SaaS for healthcare, SaaS for finance. Those companies definitely start with isolated model and try to figure out how to manage large number of databases. A lot of times those companies don't become huge. There is that many hospitals in the United States, but they still have to build all the tooling to manage large number of isolated databases. For other companies, it's more complicated. I would say maybe 70% of the time, the reason for eventually moving customers out and sharding and isolating would be performance. It's amazing how many performance problems can be solved by just having less data in each database. On the other side, there are the story where 2 years in, suddenly a very sensitive customer shows up, or you want to sell into, like you thought you were building a normal CRM or some kind of RAG database, but then a healthcare company shows up, a bank shows up, or even worse, a government shows up. And they show up with a list of demands. And since they usually have good amounts of money to back those demands, there is a lot of incentive to figure out a solution for them.
Nice. We have one kind of ugly duckling in the Postgres world that I'm not sure quite fits either of these models. I wonder if it's worth discussing row-level security briefly, because if I was to bucket it based on those definitions, it's the kind of the pooled model in a way, because all of the data is together, but there is some isolation between tenants.
Absolutely.
Yeah.
I have a love-hate relationship with RLS. I think a lot of people do. Because you're right, on one hand, it's absolutely a lifesaver in the pooled model. Developers make mistakes as joins get and conditions gets more complicated. It's very easy to misplace a work clause and actually leak data that you don't want to. So RLS will prevent you from doing it if you do it right. It turns out that a lot of times the rules get complicated and then it leads to bugs. It also turns out that a lot of times the rules get complicated and leads to terrible performance. And one thing that developers really don't realize, I'd say almost no developer realizes it until they run into it. The work conditions that RLS introduces are not optimized like the work conditions that you introduce. Because Postgres, thankfully, is very good about security, it treats the work conditions in RLS differently. I think they have, they call it security conditions or something like that. And they are very, very conservative on how they optimize it and how they plan for it. This has benefits. You get very strong security guarantees, very few bugs as a result. This is fantastic. On the other hand, the plan would be sometimes significantly worse than what you would come up with if you were to look at it really hard and do it yourself. And with RLS, there is basically no way to force the plan you want. You cannot set, enable, disable different rules because, again, the main overriding rule is that we're very conservative on how we optimize those RLS conditions. So some people call RLS a performance killer. I wouldn't necessarily go this far, but you can definitely run into gotchas, and you need to be aware that it's not a normal work conditions that you're looking at.
Yeah, nice.
So what does Nile offer today, and what is the ideal solution to all this in Postgres context, of course?
Yeah, so basically we wanted to do maybe three things. First of all, give isolation while not degrading the developer experience. So, for example, we partition data by tenant out of the box for you, completely transparently, because we know that a bit later on you're going to want it and it's going to be a pain in the ass to edit. We shard it transparently. Basically, your database may be spread across multiple different shards. We will route the queries for you and make sure that they are working as you should. So in a way, you get the model you will have anyway in 4 to 5 years, but you're getting it from the get-go. And without doing a lot of the work, because we are doing a lot of the management for you. The other thing is that we have done some work to basically bypass RLS and still give you isolation. So the queries, you kind of do the same RLS set tenant ID equal. We use that to actually direct queries. We rewrite the queries immediately to the partition that we know has the data for that tenant. So we have a small extension that kind of replaces table names with partition names in the query itself. And this vastly improves performance in the majority of cases. I mean, we've seen it. in a bunch of cases, especially if you have slightly weird indexes that RLS may conservatively not use. The improvement is quite stark. It can, depending obviously on table sizes, you can get a benchmark that proves anything. So I don't want to throw numbers out there. But obviously, if you break down a table with 1 million rows into 1,000 tenants with 1,000 rows each, then you can show you can see where I'm going with that. The other thing we did, and that was probably the most work, and this is still work in progress, is allow moving tenants around. Because one of the biggest problems is that the tenant gets large or noisy. And you want to give it its own machine. Moving it is usually a long downtime if you catch it after the tenant is already large. By doing the compute storage separation, we can basically make it transparent. It's a latency spike while we're holding off some queries, while we're moving things like setting up sequence ideas, pointing into a different compute into the same part of the storage. But it's essentially a no downtime operation. So we think it's a huge deal because, again, it's just a problem that we keep seeing again and again.
Yeah, I'm curious, is it all open source what you build or only parts of it?
Right now it's mostly hidden. We have started registering parts of it under Apache license V2. So yeah, the goal is to open source it, and we already publicly declared that it's going to be open source.
Yeah, that's great.
We have not a date, but a point of completion where we plan to open it.
Yeah, so I've heard about there's several interesting things here. So one is extension for this, like I guess it's called in your documentation it's called RLS virtualization, or how's it called?
We call it tenant virtualization. The extension
virtualization,
itself, I think we called it Karnak. We call everything after stuff in Egypt, and Karnak is a famous temple.
So data is stored in separate tables and in the same database, but extension rewrites queries to basically route query to proper table, right? Is this
so it's in separate partitions, and we rewrite queries to go to the correct partition. We basically bypass RLS, we bypass the planner trying to make those calls. We found out that with a large number of partitions, this is significantly more efficient.
I see. So it's Postgres partitioning. I see. And you mentioned also another thing you mentioned here is sharding, you mentioned, right?
Yeah, so we use foreign data wrappers to allow... So we'd have two things in the architecture. First of all, we have a proxy. It's a routing proxy, so it keeps track of every connection, which tenant is the current tenant, and it routes it to the shard that has the correct data, that has the correct tenant in it. And then we also have some cases where some developers want to write queries that touch multiple tenants. Those are not going to be as fast, but we do allow them by use of foreign data wrappers and mixing partitions with our own partitioning rules with foreign data wrappers and still keeping things efficient. We didn't want the planner on any machine to be aware of all the partitions in all the other shards, because it just explodes the planning time in ways that we saw as unacceptable. So what we did is represent each shard with a table and then put hierarchical table inheritance on top of it. And the end result is basically a union all between the table with the table inheritance that points to all those other shards and the table with the partitions. Now, this gives us basically predicate pushdown, because the planner will push the plan to all those different shards. Only the other shards know that they have partitions, which the source planner didn't know. They will plan correctly with all the partitions, but they only know about a subset of the partitions. So we see it's a bit hacky and it's a bit weird to explain. And we think we can do better with some modifications to Postgres, which we have not done yet. But this does give us predicate pushdown, fairly fast planning, and the ability to do queries that cross tenants in situations where this is required, essentially.
Yeah, if you don't involve to PC, just rely on foreign data wrappers, no two-phase commit. I'm curious what kind of anomalies can happen there.
Yes, and we prevent a lot of things that could cause anomalies. So we do have a transaction coordinator, but in order to not overload and also not overcomplicate our architecture, we limit some things. So DDL has to be done on a single tenant, and you cannot mix cross-tenant queries. Sorry, DML inserts and updates have to be done on a single tenant, and you cannot mix in a transaction cross. So the moment you start a transaction, you have to know what tenant you're working on. And then we route it to the correct shard, which has the correct table, and everything has the absolutely correct guarantees. If you need to do something cross-tenant, you do not involve it with any kind of update. You could still be exposed to some anomalies, I agree, because there could be ongoing transactions from other people in other places. So you get the basic read committed guarantees that Postgres gives you, I believe, but not anything more than that. But yeah, again, we believe that cross-tenant queries are rare and mostly done in analytical cases where you do reporting, where it's slightly less critical to have those strong.
So you forbid writing to two shards in one transaction?
If you want to write to a shard, it's fantastic. You tell us what tenant you are writing data into, and we will direct you to the correct shard.
I mean, if there is a transaction which needs to write to two different shards, this is a big problem, because without 2PC.
Yes, exactly. And we don't let you do that, essentially, in order to avoid anomalies.
I see. Another question here. Have you considered the approach used in Vitesse, as I understand it, maybe I'm wrong, where mostly for analytical queries maybe, to avoid distributed transactions, data is brought asynchronously from one shard to another, and we have it locally, like basically kind of materialized view on top of logical replication, for example, or something. And it has eventual consistency approach, of course, but you can just join it in one Postgres, in one shard, right? Have you considered this approach?
We have considered it. I think maybe CitusDB has something similar, if I remember correctly. I'm not 100% sure, but yeah, it's something that we are like, yeah, this is a good idea that we may examine in the future. It's definitely, we are trying to build something useful gradually, and we understand that early on it's almost safer to have a bunch of limitations that over time we resolve rather than allow people to do something unsafe, and also build a kitchen sink.
Sounds to me like Postgres versus MySQL approaches, because MySQL approach, you remember maybe you don't remember, but it was like quite bad. You need to run repair table all the time because it's not the CID and so on. It allowed too much,
Exactly. Yeah. And MySQL had a lot of issues. I mean, there is a reason why InnoDB became extremely popular.
Right.
But also with a multi-tenancy use case, I think you're quite right that you'll find out soon enough, right? If lots of people want these cross-tenant or cross-shard queries, which are by definition cross-tenant queries, and if you don't need to worry about it, you save a bunch of effort having to even implement that. So yeah, I like that a lot.
Yeah. Last comment here is I'm excited to see that finally Postgres ecosystem receives some attention in the area of sharding. I guess it's just time has come, and more databases became too large to be handled.
I'm honestly surprised it took that long. I mean,
Well,
again, if you look
it
at
didn't.
MySQL,
It's just unfortunate. First time I touched this topic, it was 2006, immediately when we started working with Postgres, honestly. And there was a PL proxy from Skype at that time already, but it required you to write everything in functions.
partitioning didn't exist back then.
Existed. It was based on inheritance. It
Yes.
required much more manual. It was fun, actually. You understood it better, you know. But it was not convenient, 100%. Not super convenient. It's just I see it as just unfortunate how it turned out in Postgres ecosystem, and now definitely there is huge pressure. Many companies need partitioning.
And
Need
it seems
sharding.
like, how would history work? Imagine that YouTube picked Postgres and not MySQL as their first database.
Yeah. Yeah, Google or Facebook, they both chose MySQL somehow, yeah.
Well, Vitesse would be for Postgres first, right?
Exactly.
Yeah.
It could have turned out so differently.
Yeah. It's funny, isn't it? Changing topic slightly, LLMs are quite top of mind at the moment. Are you seeing people's initial choices change as a result of asking for advice earlier from our robot friends?
Oh my God. We're seeing so many weird things. Like, it's just unbelievable how much things are changing. First of all, we're having people show up on our Discord and say things like, I'm using Nile because my LLM thought it's a good idea. And I don't really know Postgres, so I need some help, but
Oh,
my
wow.
LLM assured me that this is still a good idea. Like, a lot of people who are just like people who are very much beginners. Like, maybe I can say, when I started developing, the first time I had to use a database, my company sent me to a 3 weeks database class. I think it was Oracle, about 20 years back. And I came back a lot more confident that I know how to use Oracle and not to leave transactions open too long because people will yell at me. These days, people don't do the 3 week class before they try using a database. So you see a lot more people start using a database earlier on, and they do expect more hand-holding from the vendors. Like, the LLMs give them advice up to a certain point, but eventually, if things are slow, they will come to you and say, hey, why is my query slow? I'm sure you guys have seen your share of that. I'm also seeing people use Postgres for their LLMs in different ways, and
Yep.
this is really exciting to me. People use Postgres via MCPs, people use Postgres with vectors, people building AI applications on top of Postgres. We're seeing a lot of that. And I mean, personally, I'm really excited that people can program with LLMs, not knowing a lot about Postgres, not knowing even a lot about software engineering at all, and still get reasonable security guarantees. You don't need to know to ask your LLM about RLS or about, are you sure this query actually properly isolates tenants? And it's also interesting how much the results differ when people use different LLMs. Like, I would say thinking models do fairly well iterating in order to get good code and checking their own results, again, given via MCP access to a database. I would say that if you use ChatGPT 4.0, you will get a lot of random hallucinatory stuff still in your code.
Yeah, it's funny. I already told Michael we had the cases doing consulting, but like maybe already almost a year ago, I started noticing that people send us like some. We are building this part of database. Can you review it? We are reviewing. We use different LLMs supporting this review, and then we have a call. And I'm curious. Like, code is like looks great. I mean, schema looks great. Like, but something is off, right? And then we have a call, and I see they open tabs and ChatGPT, Claude there as well. So I realized I used LLM to create schema and then send us for review, and we use LLMs to review it. And then it's like a four-party process, you know. It leads to good place, but someone needs to jump with proper expertise and say this is not good approach.
This is hilarious. Do you think at some point you and your customer can just step out and let the LLMs figure it out between themselves?
Well, there's a problem here because like it's great, but there is it does 80% of job in 1%, not in even 20% of effort very quickly. But there is 20% of problems which again, like I don't know, maybe in next few years it will change. I think it will change. But right now I feel my internal LLM trained much better than ChatGPT.
Yeah. You trained your own LLM, right?
Yeah. No, I mean my own in my brain.
Oh yeah, no, but I think you actually trained your own.
We experiment.
We
We do some stuff. We experiment. We have some things like we have. We start with fine tuning, moving to our own LLM, but not yet there still. So yeah, there is a lot of stuff can be done there to properly. It's hard to compete with Claude, and they have a very high pace. With Claude 4 release, I see, wow, it's really great. But it's still missing many things you learn from practice, which were not discussed. That's why they don't bring it. Many problems were not discussed yet. And you explore them if you have a lot of data and heavy workloads.
So you're saying that even training on like the Postgres mailing list doesn't have all the information in it, essentially?
Well, yes. For example, random problem, we recently touched it. There is a buffer pool in Postgres, and there are 128 basically partitions. So you can have 128 locks, and if you have a huge buffer pool, this becomes bottleneck. And some people say, well, let's maybe make it tunable, configurable, right? But when you start researching this topic, you end up finding some recent, last August and September last year, conversation in hackers mailing list, which is open-ended. It's not complete because somebody needs to run benchmarks and prove that this is worth having new setting. And that's it. There's a patch proposed, but that's it. No experiments yet.
This is, by the way, one of the reasons I was so excited about your LLM approach. Because if you think about what is the bottleneck for doing a lot of the database improvement things, and I am feeling it very personally, running benchmarks is hard. Properly planning a benchmark is hard. LLMs can help with that, but again, they sometimes just go off the rails. And even if they help plan that, I don't know LLMs that actually run benchmarks to the point where they, provision the machines in AWS and knows that you have to provision a separate machine as a database and a separate machine, maybe a few of them, to drive the workload, and they both need to have appropriate resources. Like all those, and then don't get me started on analyzing the results, which is kind of 99.9% of the work. So the fact that you actually kind of started your LLM I have an LLM that can actually do benchmarks is just, I think this will be the biggest breakthrough in both people tuning their own Postgres and also Postgres as a community being able to advance the state of the art.
Let me share sad news. I'm not giving up, but it's a roller coaster. The team of maybe 5 engineers spent more than 1 year trying to achieve that. We achieved many things, but first of all, we chose Gemini because they gave us credits. And I think it was a huge mistake. Gemini has a lot of problems. They have a lot of suddenly you have 500 error, so many problems. It's just not mature product, Gemini, and it has hallucinations all the time. It's good, for example, for JSON, working with JSON, because when you need to run experiment, we decide to choose JSON as config format. It writes it much better than GPT-4, 4.0 and so on. But many things it just hallucinates. It invents all the time some things. It just makes up results all the time, and we have a system to control it, but it bypasses all the time. It's really hard. So then, we experimented with additional DeepSeek, Llama, and we fine-tuned a lot. All versions of GPT, all modern, fresh versions, we also bring them all the time. And Claude is much better. We just added it to this assistant we have. But after 1 year, I decided, you know what, I'm like, benchmarks is an extremely hard topic, and we cannot trust it anymore. I mean, we cannot trust LLM to create precise configuration and process results fully. So we decided that LLM is just, it's just more like connection thing. Like when you engineer benchmark, expert needs to engineer. I don't trust any LLM for now, because any experiment, we plan to publish maybe 15 to 20 experiments in our blog last year. And if you open our blog, you see just one experiment. And even there we screwed up, and someone on Twitter said, this is not right, and we quickly corrected, which is good. And we had achievements like interesting things, bottlenecks popped up here and there. It's really fun to iterate with LLM. But once you allow to design experiment and to treat results, in 99% of time we have wrong results, wrong conclusions, and so on. So for now we are thinking, okay, this is just accelerator of performing experiments, but design and understanding results should be in human brain for now. 100%.
I love the fact that benchmarks is also hard for robots, to be honest. It's so hard for humans, hard. Right?
Yeah, and we collect so many artifacts, but somehow it's super hard still. So you always think, where is the bottleneck? And simple question, right? But LLM, for now, it's extremely hard to let LLM find bottleneck and draw proper conclusions.
And honestly, if you just had an LLM that always said it's a network, it would be correct about 80% of the time.
What if it's local? There's no network, everything through Unix sockets, and we had these cases as well. So
yeah, I was joking.
I agree with you in production. Like in production, yes, but in experiments when we learn Postgres behavior on a single machine running PGBench locally, right? We don't care sometimes. So there's no network there sometimes. So it's hard. So I had many moments of frustration, but it's so good. Like I still believe that iterations are great. So if you say this is great benchmark, just check it on new version, just changing one thing. This is good. Like we have automation, we have interface. It repeats the process of analysis again. This is where LLM helps a lot, because without LLM you could just have some form and we don't have this parameter programmed. It's not exposed in the interface. It's bad. With LLM you have freedom to change things and iterate based on existing good benchmarks. So yeah, I cannot say we are there yet. This project, like right now, we are like thinking about next level of it, where I think we will let LLM, we will give it less freedom. That's the key, and control more by human brain.
Human in the loop kind of thing.
Yeah, exactly. Yeah. So design and first analysis, only human should be there. But once you have confidence that you're moving in the right direction, and you just need to iterate and expand, for example, to different versions, platforms, everything, this is where you can relax. You already verified the results. You can say just repeat, but on different something. This is where LLM already can bring you. It can just speed up everything. You can throw it to this benchmarking process and have like 10 experiments running in 10 different versions or something.
And I think this is also kind of almost the general directions that agents are taking shape. I mean, people started, 2025 was supposed to be the year of the agent. I think it's almost becoming the year of the human in the loop with the agent.
Yeah.
Like all the successful products I see are, you tell the agent to do some stuff, you ask it, please plan something, you give it feedback, You then say, okay, now that we have a good plan, go and execute on it. You come back an hour later, you had your coffee. Okay, let's see what you've got. Here's some feedback. Go fix some stuff. I think it's always, every successful product is a bit like this, from what I see.
Right, but sometimes humans start using different LLM when reviewing things, right? Being lazy, right?
Yes. Yes.
That's interesting. Yeah. So I'm not sure how successful it will be, but my gut tells me that we need to move in this direction anyway, and have some, I don't know, like more experiments and so on. I hope we will have more soon to publish. I mean,
Yeah.
and start iterating. But yeah, it was a roller coaster last year. So now we are rebuilding stuff. We will see how it works. And for example, one of experiments we must do, I think, is to conduct various benchmarks for RLS, because it's obviously
That would be
becoming.
a fantastic example.
Yeah,
Yes. And I mean, this is something that humans with experience are pretty good at, finding cases where you're like, is RLS going to actually be an issue? And
Yeah,
have the stories that then the LLM can go implement and test.
yeah. We had several cases, and also Superbase has public materials, blog post about this. Obviously, there is already quite known case when you have like current setting function inside RLS expression.
Ooh.
And this is, if you select count 1 million rows, it's terrible. And it's quite easy to fix, actually. But yeah, so these kinds of experiments, to collect them and see how. Actually, my goal with this experiment, I think, will be to prove that they are not a problem if you do it right.
Interesting. I would contribute, I think there was a recent post on the bug tracker where basically the optimizer, the planner refused to use, I think it was a gist index or a gene index, due to the belief that the RLS optimization is incorrect, is unsafe. I can look it up and send it to you
Yeah,
for
it's
show notes.
interesting. It's interesting.
But yeah, that can also be interesting. Like if you have a fix for Postgres, then you can. It will obviously be nice to showcase.
Right, and I think also if you so you don't use RLS, you like you said, bypass it, right?
We bypass it, yeah.
Yeah, that's interesting. I'm curious if you in this mixed schema, when we have partitions or shards and RLS, like, does it make sense at all to involve RLS additionally locally if some of shards have a mixed pool of
Actually, one of the
customers?
questions that I have in mind, and this is something that we're trying to help figure out for our users, often on top of the tenant, you still have permissions for specific users in the tenant. Like you have an admin that can do anything, and then you may have someone who is not allowed to see some rows at all because they're too sensitive, all this kind of stuff. And our users ask us, they can do it with RLS inside those partitions, or they can do it in their application. There is a lot of application level tools or like middleware kind of tools that will do it for them. Is it better to do it in the app layer or in Postgres with RLS? Is a good question that I don't have an immediate answer for.
Right, so there are several layers of multi-tenancy, basically, or well, not multi-tenancy, but different layers. And if your customer, being a tenant for you, they might have tenants for them, but also inside them they might have additional like clusters or I don't know, segments of users inside each tenant, right? So it's kind of apartments and rooms inside apartments.
Nice. I like that. Yeah. This is one of the things that make multi-tenancy confusing, right? Because it's almost like matryoshka kind of scenario.
Great, yes. This term, by the way, used in Postgres ecosystem multiple times, starting with, you mentioned GIST, original paper by Hellerstein mentions that Matryoshka, RD3, Russian doll 3, so basically Matryoshka
That's
3.
true. And also in embeddings, they have the matryoshka type embeddings where you can make them of any size.
Yeah, I read about this as well. Yeah, it's funny. So yeah, great. And what are your plans for AI? I saw MCP servers and already there is some integration.
Yeah. So we basically have three directions. One is MCP server and making it public, giving it authentication. Right now, it's open source. You can run it on your own, but we are not hosting it. So we should start hosting it at some point. So things that just make people who use LLM make it easier for them to use it. Other thing we've done that we think is very useful for LLMs, this we already have, just make it zero time to create new databases. Because LLMs just zero time and zero cost. Because they love creating a lot of them. Every time something goes wrong, okay, let's try from scratch with a new database kind of situation. So we're making it fast and cheap. The other thing that we're still working on is really to make our documentation more LLM friendly. LLMs.txt is absolutely not enough. It is actually, it creates a very large file. The LLMs tend to get lost in it. We need to figure out how to make it better. And then also, everyone is kind of thinking, can we have our own agents? Can we do something around that? We're kind of thinking about that. Something we already have that is useful is just that with the multi-tenant model, the vector indexes are much smaller. And this is a huge deal for people building those agents and LLMs.
Yeah, and actually you mentioned, so this zero startup goal, you mentioned separation of compute and data. How is that achieved? Using what approach? Can you elaborate?
Yeah, sorry, this is more than a 2-minute answer, but the short one is that you patch Postgres and then you find a better way to do your storage and basically wrap every Postgres storage function with an equivalent with your storage, and then you also need to apply the wall continuously to the storage layer.
Great job doing this in actually 20 seconds. I understood very well, yeah. So, and do you have plans to make this open source as well?
Yes, absolutely.
That's great.
I mean, this is, first of all, as you know, WAL readers have to be registered. Our already is, and with the open source license. And then, we are planning to open source our storage layer, our extension. I think at this point it's about 7 different patches we've made on Postgres. I don't think we will want to open source it as a Postgres fork because the number of patches is quite small, and we are maintaining it. I think everything from Postgres 12 to 18 at this point, or maybe 13 to 18, something along those lines.
All supported versions, I guess.
Yeah.
That's great. Yeah. Well, looking forward to checking it out. And actually, one more question for me, maybe last one. Are you open to some benchmarks? We probably will do. We plan to do some benchmarks with various platforms. It all started after acquisition of Neon, and there's a discussion on LinkedIn. So I thought about running some benchmarks for different platforms. How do you think? What are your thoughts about it?
Oh my God, this is very scary. We are benchmarking ourselves all the time. So I'm keenly aware of exactly what benchmarks make us look good and what benchmarks make us look bad. And I think that's also how we react to benchmarks in social media. Unless it's a benchmark that shows something in Postgres itself and clearly attempting to educate and help people, you can design a benchmark to make anyone in the world look bad. You can
benchmarking, it's called.
To make everyone look good. Exactly. So I'm at any given time, I can publish my benchmarks that makes Nile look fantastic, and you can run benchmarks and that you decided how to build them, and maybe very realistic, and may even expose the problems that we have that I didn't know about. But yeah, in general, I love benchmarks. I just have opinions on how benchmarks are used by marketing people.
Very, very good answer. For anybody interested in a bit more about Nile's architecture, Gwen gave a really good talk at pgconf.dev recently, and the video just went up on YouTube, so I will put that in the show notes for anybody that wants a deeper dive there. There was also a good talk I saw at a PG Day Paris event by Pierre Ducoquet. I'm not sure if I'm pronouncing that anywhere near correctly, all about multi-tenant database design, especially focusing on something we didn't focus much on today, which was the downsides of schema per tenant design, including things like observability and monitoring, which I thought was really fascinating. So anybody considering going down that route, definitely check out that video, and I'll put that in the show notes as well. So yeah, thank you so much, Gwen. I think we're out of time. It's been a real pleasure.
It's been a pleasure. Thank you for having me on.
Thank you.